Welcome once again to my YouTube channel. So today we are taking a topic on a resolution of vector. First, what is this resolution of a vector? Resolution of a vector is a splitting of a single vector into two or more components. If you are given a single vector, you can break it up such that one lies on the horizontal component, another lies on the vertical component. Such is said to be resolution of vector. Now we have a single vector, for example. We have this vector v. I can resolve this very vector along the horizontal and also along the vertical. Let's say the angle of resolution lies here. So I can resolve this vector along this very horizontal. So from here to here, I have the horizontal component of the vector. I can also resolve it along the vertical. That is from here to this very point. I have the vertical component of the vector. So now the two components of a vector, if you sum it up, you are getting back this very vector v. So in that case, we have here is the opposite to this very angle, right? While here is the adjacent to this very angle. So if we consider sine of an angle, we are getting opposite, which is equivalent to this vertical component. Okay? The opposite here is Vy is equivalent to this very side. So we have the sine all over the hypotenuse, which is V. Okay? So if you cross multiply this, we are going to get the vertical component as V times sine theta. So we have this. So this gives what? The vertical components of a single vector V. Therefore, we have Vy equal to the vertical component of vector V. Okay? Then if we consider cosine of an angle, the cosine of this angle of resolution will now be adjacent over hypotenuse. So adjacent here is what? Vx all over hypotenuse. Okay? So if we cross multiply this, we have Vx equal to V cos theta. Now this gives what? The horizontal component of the vector. So we have Vx as the horizontal component, okay, of a vector V. Now with these two formulas, you can resolve a vector along the horizontal and along the vertical. So if you sum the two vectors, you are getting back the vector. Now look at, we have a right angle triangle here. If you employ Pythagoras theory, then we are going to get V squared, which is the hypotenuse, then adjacent squared plus opposite squared. So for you to get back the resultant vector, as in the single vector, you are now going to have this. So you see, you are getting back that single vector. So if component vectors are given, for you to find a single vector, which is now the resultant of both of them, then you are using this very formula. But if you are to find the component of each of the vector, you are using the two formulas here, while here is along the horizontal, here is along the vertical. But remember, it depends on where you have the angle of resolution, because this angle of resolution might be inclined to the vertical. If it is inclined to the vertical, then this very formula will automatically change. In that case, we are going to see that Vx will now be V sine theta. So in a short note, we can just say whenever the angle is in between, maybe you are resolving a vector to the horizontal and the angle is found in between, then you are doing what? You are cosing the angle. Hence, we have V cos theta. But If the angle is at the adjacent side, then it becomes sine. That is when the angle is not in, then it becomes sine. Maybe we are going to simplify this using question. So let's take a question on that. Okay, so we have question on the board. It reads, a boy is pulling a load of 150 Newton with a string inclined at an angle of 30 degrees to the horizontal. If the tension in the string is 105 Newton, the force tending to lift the load off the ground is. Now let's analyze it using a diagram. A boy is pulling a load of 150 Newton. So the weight of the load is 150 Newton. Let's say we have the load. Now the weight of the load is 150 Newton. Now a boy is pulling this very load at an angle of 30 degrees. Then if here is horizontal level, so the angle of which this very boy is pulling the load is 30 degrees. So the boy is pulling. So the boy is pulling it through this very string. And the tension on the string is 105. This is the tension on the string. Then calculate or find what? The force tending to lift the load off. Now there is a force acting on the horizontal, which is horizontal component of the force. There is also a force acting vertically, which is the vertical component of the force. Now the very one that we tend to lift it upward is this vertical component. Resolve this very vector to the vertical. You see 105 Newton, you are resolving it to the vertical. Then there is no angle in between that very vertical component and that very force you are resolving. Okay? So you have to consider what? Sine. Remember what I said? Once there is no angle in between, you are considering what? Sine, because if you simplify it as usual, it will give you the same thing. If the angle is in between, then it becomes cos. So I'm now resolving it to the vertical. So it now becomes what? Sine. So I have 105 sine 30 degrees. Okay? So sine 30 degrees will give us half. So we have 105 times half. So in that case, we are getting what? Half of 105 will give 52.5 Newton. That is the force that will pull it off from the ground. Now let's take another exercise. We look into the question here. The question reads, above are four forces acting from a point. Calculate their resultants. So we have four forces, 12 Newton, 10 Newton, 15 Newton, and the 9 Newton. Now we are going to employ resolution of vector. So we have to resolve each and every of the forces along vertical and horizontal, after which we find the resultant of it. Now we start with this very 10 Newton. Now we are going to resolve the 10 Newton along vertical and along horizontal. Now I want you to remember, when you have components, that's x and the y component, here is a positive component of y, while here is a negative component. Here becomes a positive component of x, while here is a negative component. Okay, so you have to consider it because direction is very important whenever you are dealing with a vector. Now, to resolve this, I'm going to resolve it first to the horizontal component. Now, horizontal resolution of vector. Horizontal resolution of vector. So we resolve 10 Newton to the horizontal. So all the vectors, I'm going to resolve it to the horizontal. Now 10 Newton, resolving it to the horizontal. There is angle in between, hence we consider what? Cos. If there is no angle in between, that should be sine. So 10 cos 30. So horizontal components of that very force. So the horizontal component of the force, we are using this as the horizontal component of the force. So horizontal, 10 Newton to the horizontal, we have 10 cos 30. Okay? Remember, it is positive. That's why we have a positive value. Then plus, then we resolve 12 Newton to the horizontal. there is angle in between, hence we cos. So 12 cos 40, but it is on a negative direction, right? So we have minus 12 cos 40 degrees. Then 9 Newton is already on the vertical component, so no need for resolution. Then we come to 15 Newton, we resolve it to the horizontal. Now here is positive aspect of it. So we have 15 cos 60 degrees. It is cos because there is angle in between. So here we have the horizontal component to be 10 cos 30 degrees, plus minus is minus, minus 12 cos 40 degrees, then plus 15 cos 60 degrees. So we are going to simplify this. We have 10 cos 30, then minus 12 cos 40, then plus 15 cos 60. Then we are going to get that horizontal component now is 6.967. Okay, to two decimal place. Well, let's have it to two decimal place. 97 Newton. Then we also resolve to the vertical, having done that of horizontal component. Now the vertical resolution of vector. Now we are going to resolve each and every vector here. Here is a vertical, Fy. So 10 Newton, you resolve it to the vertical, okay? Now resolving 10 Newton to the vertical, there is no angle in between them. Hence we are going to sine. So we have 10 sine, you sine with the adjacent angle there, which is 30 degrees plus. Then 12 Newton, we resolve it to the vertical. There is no angle in between. So we sine the adjacent angle, which is 40. So we have 12 sine 40 degrees. Then plus 9 Newton is already on the vertical. So no need of resolution. So we have plus, here is minus 9. Then 15 Newton, we resolve it to the vertical. There is no angle in between, hence we employ sine. So 15 sine, adjacent angle there is 60. 15 sine 60. So plus minus 15 sine 60. It is minus reason the direction is negative. We resolve 15 and the 9 at the negative part of y-axis. That's why we have a negative value to both of them. So here we have the vertical component 10 sine 30 plus 12 sine 40 plus minus 9 is minus 9 plus minus 15 is minus 15 sine 60. So we simplify this now. We have 10 sine 30 plus 12 sine 40 minus 9 minus 15 sine 60. So in that case, we have Fy equal to minus 9.28 Newton. So that gives the vertical component of the vector. Now we've got the vertical component and the horizontal component. So to resolve the vectors, we have this. Here is the origin, right? Here is the positive aspect of y, while here is the negative aspect of y, okay? So here is Fy components. Then here is the negative aspect of x. Here is negative, okay? While here is negative, while here is positive. So the direction is very important. So in that very case now, we have Fy. The Fy on the negative, that negative shows that you are taking the vector towards this direction. So we have 9.28 Newton, okay? Then we have the F component, which is the positive. So it lies here. So we have here as 6.97 Newton. So in order to get the resultant, we take the resultant vector. Okay? Now, take the rectangular part. We are going to have this. Okay? Now, we can use this very triangle here. So if you are using this triangle here, this very side is also equal to here, which is 6.97 Newton, right? So we are using this triangle. Now, this is the resultant vector. Okay? Are we there? So we get the resultant vector. Then the direction is determined by the larger force. Here is the larger force. So the angle of this resultant will now be taken from here. That's the direction will be taken from here because this one is a larger force. Why the magnitude is this? So in order to get the magnitude, we have F squared from Pythagoras theory of this triangle. We have horizontal components, vertical components. The horizontal component squared, the vertical component squared. If you take root of both sides, you have the F. Okay? So we have F now equal to square root of F component squared, Y component squared. So let's substitute the values. Of course, we've got all the components of the vector. So to simplify, as we get the final answer, we have the resultant force, which will now be square of the horizontal component. The horizontal now is 6.97 squared. Then the vertical component, we have it as 9.28 squared. Then we employ our calculator now. 6.97 squared plus 9.28 squared. Then the F will give us the square root of 134.6993. Then we take the root of it. Then it's going to give us 11.61 Newton. So we've got the resultant vector, which is 11.6. So in order to get the direction, remember this is just the magnitude, okay? The magnitude of the vector. So in order to get the direction, you see the angle, which is the direction, opposite here. Here is adjacent, which means we're employing tan, which is 2i. So in order to get direction, we have tan of that angle go to opposite over adjacent. So we have 6.97 all over adjacent, which is 9.28. So we divide 6.97 divided by 9.28. So we are going to have tan of an angle 0.75108. So make theta the subject, we have tan inverse 0.75108. So if we punch that, the tan inverse, it will now give us the direction to be 36.91 degrees. So in that case, you see that the vector itself, which is the force now, is equal to by magnitude 6.61 Newton, and the direction is 36.91 degrees. That gives the answer to the question. So if what we did was able to help someone out there, please do subscribe, share, and turn on notification for others to learn as well. See you on our next class.